So for 9.3 notes, we're going to talk about comparing functions. So in example 1, we have 3 trains, A, B, and C, and they leave the train station at the same time. The graph shows the relationship between time and distance for train A. The equation shows the time and distance relationship for train B, and train C is shown by a table. So we're going to go through each of one of these one at a time. So let's look at train A. The y-intercept is 0, right? And then it looks like the next time that it crosses through a coordinate point is at 2, and then halfway between 40 and 80 is 60. So it is going up 60 over 2, which reduces down to 30. And this slope represents that it is 30 miles per hour. So that's how fast that train A is going. Train B is given above, and we need to look at the slope m. So y equals mx plus b. Well, the b is going to be 0, just like the b would be for train A. But the m is 45, which is 45 miles per hour. So which train is moving faster, A or B? Train A was going 30, train B was going 45, so train B. And we know because it's going 15 miles an hour faster. But the time-distance relationship for train C is shown in the table. What is the ratio of distance to time? So I rewrote mine over here off to the side so it's easier to see. And it looks like x every single time is going up by 3. And y from 105 to 210 is 105, 105, 105. So it looks like it is going up 105, that's my change in y. So change in y over change in x, and the x is going up by 3. If I divide 105 by 3, I get 35. So it is 35, or 35 over 1, and this is miles per 1 hour. So train A, again, was 30, train B was 45, and train C is 35. So if I were to compare, train B goes the fastest. The middle one is C, and the slowest one is A. Well, water is pumped into 2 aquariums, P and Q, so we have both of those in tables. And we need to look at the amount of water, Y liters, and the time taken, T minutes, to pump the water into each aquarium. So remember that when you have a table, the first one listed is always the X, and then the second one listed is always the Y. So let's look at the change in Y first for aquarium P. From 70 to 120 is up 50. From 120 to 220 is up 100. And from 220 to 320 is up 100. So far it doesn't look like it's linear, but we need to see if the X follows suit. 5 to 10 is up 5, then 10 to 20 is up 10, and up 10. So we have a change of 50 over 5 and a change of 100 over 10. It is linear if these reduce down to the same thing, which they both reduce down to 10 over 1. Now we're going to look at aquarium Q. So from 95 to 170 is 75. From 170 to 320 is 150. And from 320 to 470 is 150. 5 to 10 is 5, 10, and 10. So again, we're going to double check and see if it's a linear equation. So I have 75 over 5 and 150 over 10. Those are the two that I have to look at, and they both reduce down to 15/1. So, which one's faster? The one that's faster is going to be aquarium Q. So we're going to write an algebraic equation for both. So let's look at aquarium P. So for aquarium P, Y equals, well, this one is pumping 10 liters per minute, so, and it says to use T minutes. But where does it start at? So if this is 0, we have to know when x is 0, what is y? Well, we're going to go back by 5, which means we're going to have to go up by 50. So this is 20. So 20 is its starting liter. And then for aquarium Q, we know that it is going 15 per minute. And again, we need to know 0, so it needs to go back by 5. And this needs to go back by 75, so it starts at 20 also. So which is filled with water more quickly? The one that's filled with water more quickly is the one we circled up above, which is aquarium Q. So aquarium Q, because the slope is 5 more liters per minute. So which started with more water? They both started with the same. So they were the same. Both started with 20 liters.